Good evening, participants. Good evening, sir. Dr. Padmabhan, sir.
Good evening. Good evening.
Sir, welcome, sir, for today's session. Sir, we will start the session. Participants will join soon, sir.
Sure.
Yes, sir. So, good evening, everyone. It gives me great pleasure to introduce our esteemed resource person, Dr. Srinivas Padmanabhuni. So, Dr. Srinivas Padmanabhuni was awarded the title of Eminent Engineer by the prestigious organization Institution of Engineers. The award was given to Dr. Srinivas Padmanabhuni in recognition of his experience and contributions to the profession of computers at the 32nd Annual Convention of IEI. His vast experience in the computing field, including marquee area of artificial intelligence, brings a unique blend of academic, research, and industry orientation, a rare combination. Srinivas Padmanabhuni is a PhD in artificial intelligence, and Srinivas Padmanabhuni co-founded CityMandi.com, a next generation AI-enabled smart B2B startup in agri-tech focused on farm to fork. He has been the past president of ACM India, the top professional organization of computing professionals. He is the chief mentor for Tara Technologies, an AI consulting and training company. He specializes in area of software engineering, AI and machine learning and cybersecurity. He is also co-founded a responsible AI startup testing ALNG.com. Earlier, he was a principal research scientist and associate vice president at Infosys, where he overlooked the university innovation ecosystem, alongside research and innovation group in Infosys Labs. He has won several other awards, including the Excellence Award for Innovation at Infosys, Research Excellence Award at University of Alberta, and Merit Award at IIT Kanpur. He is a PhD in AI from University of Alberta, Edmonton, Canada, specializing in AI prior to PhD. Sir, we welcome you, sir, for today's session. I request Dr. Padmanabhuni, sir, to take over this session.
Thank you. Thanks for the opportunity. Just wanted to check if my slides are visible.
No, sir. Slides are not visible, sir. Yes, sir. Now it is visible.
Okay.
Yes, sir.
So I will talk about today a bit on the technology side in the sense of what AI means for industrial AI and Industry 4.0. And also make the participants do some work that I promise, because it's not just going to be one way. So please be attentive. There is a quiz at the end of the session. So I would like all of you to pay attention. So this is not just going to be just one session where you just listen. You have to also participate. That is the
Yes, sir. Sure.
okay.
Yes, sir.
Please
Sure.
make notes as you go along. It's very important because the quiz is going to be something which I'm going to announce at the end of the last 15 minutes will be the quiz. Means somewhat like what recapitulation of what you've done. Okay. So just wanted to also tell you that my company, AI Ensured, is a responsible AI company. We work in areas like AI compliance and validation of AI systems for ensuring fairness, security, privacy, and transparency. And when we talk about any of industrial AI today, immediately one thought comes, which is sensors. But then what you need to also understand is to get value from the sensors and the data from sensors, you need AI. Like yesterday, I'm sure you must have heard of Dr. Mahesh Kumar's talk of different applications where AI is superimposed on top of data from sensors. That's when you create the winning combination. So what we're going to do today is I'm going to go delve deeper into the technology and business combination, where we're going to see how AI models can be used to formulate business problems in the industry setting. So it's not like I'm going to go deep into actual models, but I'll go talk about how models meet the industry problem. So what is industrial IoT? As all of us know, it's about data from sensors, IoT devices, and AI is applied on top of it. So once we have this combination, what happens is it is the role of the AI experts to make sense of all the data that is coming from sensors. So today, unfortunately, there is no concept called AI. AI is many different things all rolled up, and people generally just use the word AI. But what I want to do today is I want to demystify AI. AI is of 10 different types. It's not like one AI fits all. Okay. So let's get into what are those 10 types of AI. Okay. But at a broad level, let me tell you, in terms of where you use the AI, is where you see difference between what is called as consumer AI and industrial. Industrial AI is basically about sensor technologies embedded in industries like automotive, supply chain, transportation, manufacturing, etc., and applying AI systems on top of it, right? Whereas consumer AI is more about like if you have e-commerce, customer service of banks, personalization of scenarios. So what those do is those things actually help you in creating consumer data and consumer process, and that also gives some kind of a idea that we need to be careful about when we're trying to deploy AI. What is the use case? Is it a consumer or is it industrial? So in our case, we're talking about industrial AI. But to me, when it talks about AI, we don't distinguish between as a consumer or industrial, because for us, data is data. So what I'm going to concentrate is what are those 10 types of AI? So the answer you will get away from today is AI does not mean one thing. It is 10 different problems, 10 different types of AI. You'll hear it from me only first time, because people will talk all kinds of crazy things about AI being this, that, no. But let me onion peel it. There are only 10 types of AI. There are many variations within those 10. You can vary and all that. But let me give you that broadly, most of the AI problems fall into this 10. But then when we talk about AI, again at the same time, at the top level, the 10 fall into two different categories. One is what is called as the concept of different techniques which can be considered as pattern recognition, which is what we use machine learning based discriminative pattern recognition. Another is what is called a generative AI, which is basically called as the idea of how you can use LLMs and etc. to synthesize scenarios, right? So that is what we'll be mapping the industrial AI. Before going there, I'll just repeat some of the things which you must have heard yesterday also, saying why is industrial AI so important? Primarily in industrial Internet of Things, Industry 4.0, idea is that, you know, instead of having a reactive maintenance of assets, machines, belts, sensors, etc., can we come up with a way by which we can detect potential failure scenarios before some actual asset failure happens and bring up preventive maintenance? So that is the biggest use case. So you need to understand is that preventive maintenance is the key use case across most of the industry 4.0. But that does not mean that there are not other use cases where AI can be imposed on top of data generated from sensors. We could do things like diagnosis of machinery, where is the fault, or you can get details about supply chain traceability, understand where is the good stuck in a supply chain. Asset monitoring, or monitoring assets in terms of a machine or a conveyor belt or some physical hardware device. Or you can do things like auto telematics, where you get data from the car. Or you can get asset performance management, understand how it's performing over time, is it degrading. So like that. Or you could get things like process improvement. Currently this is the way you look at things, and how do you improve the process. That's another way of doing things. So these are all the different use cases where AI is intersecting with the data coming from sensors. So when you talk about AI intersecting with the data from sensors, it is also important that you need to take into account the concept of what is the problem mapping to in terms of AI problem. So that actually brings us to the question. I told 10 types of AI, but broadly, if you see most of the tools out there, whether it is from IoT Suite from IBM Watson or G Predicts, or let's say AWS IoT Analytics, or Siemens MindSphere, they're all trying to create one of the kind of AI, these 10 kinds of AI, out of the sensor data. That's the goal, right? So there are several platforms coming up. And these are really getting more and more popular in the Industry 4.0 scenario. In fact, now people are talking about beyond the concept of Industry 4.0, they're also talking about Industry 5.0. So that is something which is a very, very, very powerful, concept, where people are saying that why only make sense of the data? Why not we convert into action also? That is where you create more ambient intelligence, where the environment itself is so smart that it figures out there is some problem and automatically does the action. That is where, I think some kind of agentic stuff will kind of come in and take automated action, not just necessarily involving just an AI layer, but also an action layer on top. That's where it's called Industry 5.0. But currently, let's stick to AI on IoT, which is basically Industry 4.0. So, what are the AI techniques broadly? I would say there are 10 techniques are broadly brought into two categories. One is called a generative AI, where the goal is not to find patterns in the data. Our goal is primarily to find data based on what you already know and generate new data. That is called a generative AI. Then we have discriminative AI, which is also called a machine learning. So when we talk about broadly AI, we need to understand, are we doing pattern recognition or are we doing generative AI? So we need to be very clear. So there are 9 kinds of patterns in discriminative AI or machine learning. Then one pattern, which is the generative AI, where you try to use the AI patterns to generate new data. Okay. So having said this, we'll say there is generative AI, one pattern, one kind of problem scenario. Another is all kinds of 9 kinds of machine learning, which form the discriminative AI. So let's look at what is generative AI. Please note, generative AI is not meant for just recognizing pattern in the current data. Its goal is much beyond. It says you're trained to understand pattern in the existing data. Structured data, sensors, 3D signals, speech. But it doesn't stop at understanding patterns. It goes beyond. It says that can you generate content which is similar to what you have learned from and a new kind of data. There goes generative AI. So generative AI purpose is not to just recognize patterns. It doesn't stop there. It says if you have large corpus of data, you understood the patterns from there, but you use the patterns extracted from that to further create something like new similar data. Okay, so that is where the concept of generation comes in. That's where you have the concept of large language models. So what is large language models made up of? They're made up of training on large volumes of text from the internet, large volumes of images from the internet, large volumes of speech from the internet. Then what are they used for? What is generative AI used for? Generally, it's used for some kind of summarization of information or creating new data from text, create new images, or given an image, create text from it, captioning, or answer questions based on what you learned from the web. Follow instructions. Like, for example, you say, okay, you behave like so and so. Now, based on what you know, you do this task of doing this and this, recognizing objects. So what happens is these are the typical use cases of generative AI. Goal is to go beyond pattern recognition from large volumes of data on which it has learned, but it is also about making sure that the patterns you've learned is going to be used in generating lots and lots of similar data. So what are the use cases where generative AI will be useful? Let's say you have some scenario where you have certain kinds of sensors and you're generating some data from the sensors, right? You are using the sensor data, generated data. But what happens is, let's say one kind of sensor is very, very costly and you don't necessarily want to spend in too many of sensors of that type. So what you may want to do is you may want to use a scenario of, okay, I'll not invest in too many sensors of that type, but I'll get some kind of data, some sensors of that, look at the data that is generated from that, and I will recreate similar data so that for AI, I will feed input a large volume of similar data. So I don't necessarily restrict myself saying that, oh, I'm generating very small amount of data from my current sensor, so I will not be able to do good justice to building the AI layer on top. So there generative AI is very useful. So again, let's say one more scenario. So for example, when you want to train, let's say, repair people on what kind of defect you may encounter in this kind of an engine. It's not like very often you have failure scenarios. So, but what you may have is you may have some past data of certain failures and you have captured some images. So what you may want to do is you may want to create some kind of a video using something like Nano Banana or VO3 or Sora, etc. tools and generate a video which is similar to the scenario which you have seen earlier in the failure scenario. So I'm trying to give you scenarios where the kind of AI, which is called generative AI, will be useful in industrial scenarios. Because ultimately, goal here is to train the repair personnel on understanding similar scenarios, right? Or let's say you have a training manual where you have certain scenarios you're mapped out, but you don't have the videos of all kinds of variations. So what you may want to do is you may want to take existing video, feed it to Gen AI, create similar videos for training purpose. So I'm giving you several such use cases. And the idea of several such use cases is primarily that even in the industrial AI scenario, it's not that you know all kinds of data which is required for making your appropriate actions in terms of predictive maintenance or in terms of asset monitoring or in terms of recognizing defects, etc. So you need to overcome the deficiency of sufficient amount of data, especially on the abnormality side. When you have defects, etc., it's not that you have a lot of defect data. So what happens? You defect data, whatever you have, you use Gen AI to multiply. You try to create large volume of the defect data so that you can use the generative AI to, feed into the training process for applying for use cases like, as I said, as we discussed, the use cases like something like predictive maintenance or diagnosis. So in that case, what happens is it is not that we will only depend on what data you have collected. It is not restricting you to data you have collected. You are using the power of generative AI to collect and simulate additional data with Gen AI before you can run a predictive maintenance kind of a discriminative AI, ML model. So, so, so generative AI is definitely useful. So what you need to understand is that while people have been mainly talking about sensors, data extraction, AI layer, but you need to understand that it's not always that we only use existing data. You may always also have scenarios where some of the rare kind of data you need to use generative AI to complement the existing data to get the corresponding value from it so that you can apply ML on top of it. Okay. The next comes whole concept of discriminative AI. And this is where I think most of the IoT use cases are. If you look at majority of the use cases around preventive maintenance, predictive maintenance, asset monitoring, process improvement, or detecting defects, all of them fall under this particular category of what is called as discriminative AI, also known as broadly machine learning. Machine learning is technically nothing but pattern recognition in data. What is pattern recognition in data? That means in the data which you have captured, is there some kind of a regular pattern which is identifying commonality between the different parts of the data, and that pattern is what extracted from input data, and that is where we're using it to discriminate between different variations of the pattern. It could be as simple as, like, for example, a defective machine part versus a normal part, right? Or you can say a normal conveyor belt versus something which is worn out, which may be potentially tearing apart. Or in very simple terms, a machine rotating at normal speed versus something which is rotating abnormally. So there are several kinds of patterns you may want to extract from raw data, from sensors or generative data. So what is the idea of how you get this done? You take raw data and you apply inductive machine learning models on the data to extract patterns. Patterns could be rules, could be models, could be knowledge, could be program, could be different kinds of ML models are there, right? But the beauty of this is that it's entirely data which is helping you generate what kind of pattern you will extract from the raw data. And the other thing is you will not have any explicit way of controlling the model. It's not like a program where, oh, if this, then this, else this, and you are written in Python, then if some debugging have to be done, you go and change the some part of the program. But here you don't have that. Unfortunately, there is no way you can control the model or the program. It's always data in, program out. So how do you debug? How do you find problems in the current model, and how do you update it? And that is where we use the data and look at what kind of problems are there in the current model, and then go back and change the data. And sometimes you increase the amount of data available by using generative AI. So the idea is the more the data you have, the better is the model performance, right? So what happens in this case? The more historical data you give, the better it is. It improves with experience. For example, AI called deep learning, which works with neural networks, it works with thousands of records. It cannot work with just simple hundreds, right? So that's where you see that they probably perform much better compared to ML models. So, can people be silent, please? Okay. So, deep learning works with thousands of records, not less hundreds. So, machine learning, deep learning, these are all what is called as discriminative AI based on the idea that we're extracting patterns from the raw data. So, as I said, model can be a rule based, could be an equation, could be brain like structure like neural network, or it could be graph. But then the problem is in terms of the whole pattern recognition, there are usually considered as three types. And this is something very important. So, as I said, there are different kinds of AI, right? It's not like one AI fits all. We saw generative AI. That is one kind of AI where our goal is to generate more and more data. Then the discriminative AI, which is the pattern recognition, which is also called machine learning, is not one size fits all. There are several variations of the so-called machine learning. And when you talk about that kind of a approach to machine learning, there are usually what is called as a concept of what is the level or detail of input data that is fed into training of the model. Okay. So the idea is you don't want to get into the scenario of always needing detailed data in order for extracting patterns. That is the basic idea. Then comes what is the level of detail that is required in the input data before you can apply any kind of pattern recognition for machine learning. And that is where we have a huge problem in certain domains. It may not be possible to get predefined input data rich enough to allow a machine learning program to evolve and develop a model on top. So those cases will probably work with very little or no data, and then you'll try to collect data as you go. So that is where reinforcement learning comes in. That means no background data, but you work with reinforcement learning to gain data as you apply the system, try to learn from experience. Then you have scenario of unsupervised machine learning where you say that I only have raw data. I don't have any concept of this in the raw data. I have this is input, that is output. It's only about raw data. The raw data itself is considered for understanding patterns in the raw data. Okay. So having said that, can you now look at each of the categories of your input data problems and patterns you want to extract from the raw data into whether they have no background data or they have background data which only has input? In that case, it will be either reinforcement or unsupervised. But the most common scenario which we normally use is what is called as labeled data. Labeled data means there is input and output. In the data itself, which is given as input for the machine learning problem, you have both input and output. You may be surprised. What is this output? So I'll give you a scenario. Let's say I'm trying to find and create a model to identify some production defects in the finished products. So what I'll do is I will take images of normal, correct, defectless products. Then I will take defective products. So I have two classes, a product set which has either defect or no defect. So if you take the output variable as has defect, it will become 0, 1. So there are certain output variable here called defect present or not. And for each input image you've taken, you can associate, is it defective or normal? That means you're giving input and output, and then you train the model to identify if given a new product, is it defective or normal. So what is happening here? In this case, we're talking the language of labeling. Means each input has an associated output label, defective or not. But what happens in the real world is that, this kind of a input which is required for creating an effective machine learning model is usually done by not just collecting input data, but putting lots of people. It could be BPO companies, it could be your smaller companies who are deploying human workers to actually go and label each of these images. Only when you have a complete labeled data, then you can apply the concept of pattern extraction from the images so that you know which of them is potentially defective, which of them is not. So that category where you have input and output is called supervised machine learning. So now you see you have three grades. One, you said, I don't have any base starting data. I will learn as I go. That's called reinforcement learning. So what happens in reinforcement learning is that we usually work with a concept of learning from experience. As you run more and more number of times, you learn and calculate the cumulative knowledge. And that is where you try to use this concept of reinforcement learning to learn from experience rather than see if you are able to create a set of, monitoring the performance of, let's say, an AI program or agent, see how it is failing or succeeding at every step, and then compute the cumulative performance, see how you can get incremental knowledge in every step. So I'll just play a small video to show you what is called as reinforcement learning. So reinforcement learning, as I said, is concept of self-learning. Does not have any past data. So what you do is you actually look at each state which has many possible moves, and some moves could be rewarding, some moves could be negative punishment. But what happens is you improve the performance of reaching the goal by, incrementally either adding rewards or decrementing. And at the end, it's so powerful, the knowledge is that at every point, what is the best move. That is what is concept of reinforcement learning. It's so powerful that, let me tell you, what people are saying is, maybe this is the way you need to go forward for advancing AI to next level. Yesterday, you must have heard of Dr. Mahesh saying that AGI, right, is where you look at general intelligence, human level AI for all tasks. So people are saying reinforcement learning is probably the path where you don't need labeled data, but you need a bit of self learning. Okay, so let me play a small video for that. So please see the video.
In the corporate world, if you come across as too nice,
Problem
people
with these
don't
ads
respect you
is that
more.
they're not leaving.
They just assume you can be pushed around. You become.
Okay, please watch this video. There's no voice, so don't worry. Okay, so basically you must have understood, right? The way it learns is not from initial data, but as it plays, it tries to understand how well it is able to the base criteria to be given a reward. Reward is based on the domain. That is something a static data you give. This move is correct. This move is not correct. So that is something. Base reward and punishment is a static data. It's not something which the problem decides. Okay. So what you need to understand is that at the end of it, we need to be able to come up with a cumulative, reward function, which is so powerful that even historical label data will not give you that level of accuracy. So reinforcement learning is very useful in dynamic scenarios where you don't have initial data, you learn as you go from. Like for example, let us say I'm just trying to give scenarios in a factory floor where you're trying to let's say adjust break time based on learning from what are the reactions from people. Is it good from 12 to 1 or 12:30 to 1:30? You try to use different timelines for different months, and you find that maximum utilization happens when it is between 12:30 to 1:30. So that's a learning from experience, right? When different times you tried, and then finally you say this is probably the best, more effective way when people are more able to get a real break. So like you're learning over several iterations what is the best possible time slot. That's a simple example I've given you. Okay? Or the way you look at any kind of a scenario where you're trying to understand cumulatively improving the function of how you understand quality. So there are scenarios where you don't have to have a predefined model, but you try to look at every round,
ఏం
you try
ఆడుకుంటారు
to
ఇక
put a
ఏం
quality
ఆట
level and see how it improves over a period of time. Okay, so that is reinforcement learning. And then let us come to this whole concept of supervised learning, where you said that there is input and output. Both data are mandatorily to be fully present and given before you can apply the ML algorithm. So, for example, in defective versus non-defective, you have to make sure that if you have hundreds of data, each row has either defective or non-defective. The data mapping is important, labeling is important. But then what happens is, in this case, how you work is you take part of the data as training data and then apply the model, understand how it can perform on the remaining data. It's called test data. And that is where you see how it's performing. Depending on that, you'll choose the right kind of algorithm, which gives you the best predictive performance. But this is where you normally use the concept of mostly what is called a supervised classification. What is supervised classification? Where you have fixed number of output values. Let's say in case of defective, non-defective, 2 values, right? Or let's say we have scenario of a financial model where you're defining customers into 3 categories: high risk, low risk, or no risk. Or in case of defective material, it could be just defective or non-defective, binary, 2 classes. So when you have a fixed number of output classes, very small number of classes, it becomes a question of classes. Each one is called class. So it's called as classification or categorization. So you take the input data and try to categorize into one of the output categories or classes. Many ML problems fall into this category. And then what happens is when a new data comes in, you will be able to put this is the class corresponding to that. So if you give a new finished part, you'll say it is damaged or correct based on what it is understood from historical, trained, defective, and non-defective. That's again where I'll say GenAI can be useful because the defective category may have very few training samples. So you may want to complement it with more generative samples from defective samples and create more data for the defective category, right? So, but it is not that in all cases the output variable can be fixed number like classes. In some cases, you may just want to get a score or some probability or some continuous value as the output. Like for example, let's say in case of automotive, one very important thing of course, in India also you see in the ad, right? Kitna deti hai means how much kilometer per liter does the car give? That's called fuel consumption efficiency. So this is something based on model, time of the day, age of the vehicle, engine weight, all kinds of things. How many cylinders it has, all that becomes an input for actually computing a fuel efficiency, right? So for that, you'll take hundreds of cars of different ages, different number of cylinders, and find out what their mileage is. Based on that, when a new car or some new input you got from some old car or medium car, new car, and then compute all the input data like number of cylinders, how many, what is the typical acceleration it takes, what kind of year of the model, all that will take, and then based on historical data, you'll try to predict what could be the potential mileage this will give you. So that is basically an automotive scenario of a typical use case of output being a continuous value. What is output? It's miles per gallon, kilometer per liter. It's a continuous value. It's a numeric value. So same thing. Let's say you've seen past data about based on historical data of cracks, etc. How much time remaining for a particular machine to be still working, remaining time, or something like what is the remaining life of the particular machine. You want to predict. That could be in time in terms of number of months. So that's something you predict based on historical data. If you've seen chemical input data and seen how you could predict that. So what happens is in that case, output is a continuous value. That is called as regression. Regression means it is a continuous value output, which is based on the idea that based on lots of input data where you have input and output value combinations, you will say a new input scenario and you will predict the output. Okay. So this is basically what we talk about as regression. Okay. Supervised regression. But then what happens in the real world is many times you don't have output like category or numeric value. You just have raw data. That is most commonly what is called unsupervised machine learning or unsupervised discriminative AI. No output value, no output variable, just identifying patterns in the raw data. So what kind of unsupervised machine learning can we think about? And that is where we have scenarios of the concept of what we call as identifying just any kind of pattern in the raw data. Okay, so what kind of scenario you can think about? Let's say we have different kinds of pattern of unsupervised machine learning, but the most common one, which is very common, is what is called as clustering. Unsupervised clustering. The idea of unsupervised clustering is related to, it's basically the idea of what we call as the formation of groups of similar data. When you say here we're doing clustering, we are not explicitly having a detailed set of output variables. In classification, we know what are the output variables, like defective, non-defective. But here, there's no output class. So the data point is not labeled. So what you do is you group the items into different groups where within one group, they're very close to each other or very similar. For example, you may want to identify, different kinds of, vehicles based on their emission characteristics. Based on their emission characteristics, you may say, okay, these are vehicles which are probably high pollution. These are vehicles which are probably medium pollution. These are probably high pollution. Something we're not actually explicitly categorizing, but you just form groups of data which are similar pollution kind of data. So what happens in that case is that you are trying to form a pattern in the raw data by identifying data which are similar to each other. For example, as I said, you can identify different groups of automotives based on the different pollution patterns, right? Or let's say even you take sensor data. You can take, maybe the pattern you see in the sensor output from the graphs, etc. You're seeing that, okay, this group of sensors probably is similar. This group of sensors is similar. This group of sensors is similar. So for example, that's the way you find to identify groups of sensors which are similar. This is very useful, especially in market research, especially where you're trying to take customers, consumers, and trying to identify what are the different kinds of potential segments of customers, and then you decide what products to be developed based on different categories of customers as you convert each of this cluster into a category. You convert clustering into a classification. But that's a bit more involved, but don't worry about it. From raw data, you just form groups. As you can see here, from raw data, you're forming 4 different clusters. So there, what idea is, how do you identify similarity? What's the distance between data, which is actually going to identify that these are forming in the same cluster? So basically, the challenge here usually is identify similarity by means of some kind of a distance function between different objects. So you need to understand that when we're talking about unsupervised clustering, it is always about finding groups of similar data based on the notion of similarity, which is a mathematical function called distance between the two elements. So as I said, it could be like similar vehicles based on pollution characteristics. It could be based on sensors based on emission data. Like that, you can have groups of different things. But what you need to understand is that this is not classification. See, in classification, you need to be very clear that we predefined know the output categories. Each row, we know what is the category, the fixed number of output classes. In clustering, we don't know whether it will lead to 3 clusters, 4 clusters, 5 clusters. We don't know how the data is, how the grouping of the data is within that is. So clustering is not based on any predefined notion of how we will like to look at the data in terms of different categories as present with the data. So it's basically discovery of the pattern, discovery of raw data, pattern in the sum of similarity of the data. So you see here, each of the examples is showing that whatever are the close enough within a cluster, they are close to each other. But if you look at another cluster, they are far away. So that is the way you identify clusters in the raw data. Then comes the most important and very commonly used technique in industrial IoT. This is called anomaly detection. And this has a characteristic. The characteristic is it detects unusual data points within a large data. That means these are not very high in terms of frequency. So maybe in 1,000 you have one, or in 100 maybe you have one. So what happens is these are anomalous data points. Anomalous data points are something where you try to use the concept of finding, those data points which are far away from others when you map out some kind of a distance. So typically, let's say in industrial production scenario, if you look at very ultra high precision manufacturing scenario, defects will be very small. So in those, finding a defective produced item will be very rare, maybe 1 in 1,000. So what happens in those cases? The idea is that out of 1,999 are normal and one is abnormal. So people may be saying, why is it not classification? It's not, because classification has the requirement that most of the data classes, each of them should have reasonably matching number of, typical frequency of data. But here it's abnormal. One of them is really, really different in terms of frequency, very small frequency. So you cannot use metrics like accuracy here. What happens in this case is, if you use accuracy, I'll have a very simple dumb mechanism. Let's say I'll say I don't do any ML, but I'll say, let's say there is no defective piece in this. You know what the accuracy of that? If you have 1 in 1,000 defective, the accuracy of that is 99.9%. 0.1% is what is misclassified because it was abnormal, classified as normal. So we cannot use accuracy. So we need to understand that anomaly detection, that's why it's a separate category of ML. It's very important to understand that. We have several techniques like isolation forest, or you can do stratified, classification samples, etc. But the point is, in Industry 4.0 scenario, this is a very, very important category of ML in terms of identifying a discriminative pattern of what's a defective versus not. In financial scenarios, it could be about, even in the industry, I'm sure there are scenarios of financial scenario where some fraud happens, some fraud transaction compared to normal transaction. They're not very often, they're very rare. So scenarios which are rare in an otherwise normal world is the main focus of this. Okay, so that is called unsupervised anomaly detection. And the next one is very, very interesting. This is something where I want to tell you that it's something we come across every day. It's basically about looking at raw data effectively. If you see, that's what is alternately, let's say I go to amazon.in, okay, and then let's say I try to buy something. Let's say I buy Harry Potter something. So let's say I want to buy Harry Potter and the Goblet of Fire. Sorry, I think it's gone to video, but I'll show something. See, when people are saying that I want to see this particular movie, it showed people who watched this, they also watched this. That means if you have bought X, I'm also seeing that customers watched this. So this is in terms of watching. But let's look at an example where, let's say, I just look at something which is a paperback book. So there it was about people watch this, they also watch this. Here I get a prompt which is like frequently bought together. If I bought that, people also bought this. So products related to this. When somebody bought this, they also bought this. So what happens is, the idea of this is that we try to find out what is a associated book along with this, a video associated along with the current one. So that is what is called as association rule mining. The idea is, if you have identified X, what can be Y which is related to that? Identifying items which are frequently bought together, washed together. So if you buy one of them, you recommend the other one. So in fact, you'll be surprised that Amazon gets 20% of its revenue from this one algorithm, which is called as unsupervised association rule mining, or also known as market basket analysis. So what it looks at is, it looks at basically, if you have something you bought most often, like bread. So it may recommend you butter, because many times people buy bread along with butter. Or in case of industrial IoT, let's say, for example, if you see that the conveyor belt is getting worn out, but many times when the conveyor belt is worn out, you also see that the spindle of the corresponding rotor, that is also getting worn out. That means they occur together. So if you identify one is wearing out, you'll also look for repairs in the spindle. So the idea is co-occurrence. You identify co-occurring patterns of when X happens, then Y also will along with that happen. That's called co-occurrence. May not be only in e-commerce. It could be, like I said, right, repair scenario of one gets repaired, the other also gets repaired. That's a scenario where you're trying to use unsupervised association rule mining of identifying co-occurring data points for an ML scenario, where even in industry setting, where you have some defect, you found one thing, then other defect also, other part also gets defective. So that means if something gets defective, you also look at similar defects in the other part, which mostly always has defects along with this. So what happens in association rule mining? You look at what have actually been bought together. Only then you try to use this to identify if X is bought, then you also recommend Y. But what happens is, this is a very poor way of recommending. It says that, oh, I see only because they occurred together, I'll recommend it. But what is important is, in reality, people are not only basing their marketing or choices based on whether they're bought together. They also look at what are the characteristics, are they similar? So that is where Netflix and companies like that, they said, I'll not be basing purely on Amazon kind of recommendation system based on association. Can I look at items and see if, based on what I have purchased earlier, can I recommend an item which is very similar to the items which I bought? That is called item-based collaborative filtering. Based on similarity of items which I bought, I will be recommended a new item. For example, when you see a lot of times in Amazon Prime or in Netflix, you will see Netflix recommends certain new serial or some new episode based on what genre of movies you've seen, what kind of sitcoms you've seen, what kind of OTTs you've seen earlier. Based on that, you'll recommend similar item. That is called item-based collaborative filtering. So among many possible new choices, you will be recommended one which is close to the one which you have already purchased, right? So what happens in this case is, you do not have the luxury of having data like what people have bought together. Instead, what you're recommending here is based on just association between the items based on their characteristics. Like, for example, based on what you have seen earlier, you may be looking at more mystery. Let's say you're looking at more like, Alfred Hitchcock kind of movies, etc. So based on that, it may suggest you a new Poirot movie, which is a mystery genre, right? That's basically similar to what you've seen earlier. But a lot of times when you actually have a scenario of, such base of comparing the items. So what happens is, if you're trying to, identify items which are similar to what you have transacted earlier, that is based on having enough history of purchase for a particular user. But a lot of times it's not about maybe individual user. It's about maybe I don't have enough history of my current user, but I know that this user is in very similar circle of friends who have similar taste. So there, what you do is you then ask their friends who are similar taste as you, and then take the one choice based on what your majority of your friends are recommending. That is called as user-based collaborative filtering. So in user-based collaborative filtering, the idea is talk to many people who are similar taste as you, and then based on what is their choice, you will take that choice. That is where you call it as user-based collaborative filtering. Whereas in case of item-based, you don't need to have multiple users. It's within same user, you look at past history of what items you purchase. Based on that, you'll recommend. So item-based similarity is used in item-based collaborative filtering. And it's more scientific compared to just having associated in a lot of transactions together. That's why you're recommending as per association rule mining. So this is more scientific. So most of the modern recommendation systems use this concept of item-based collaborative filtering. Or you can use user-based collaborative filtering, where you basically look at what kind of people you are in company with, mostly their likings, and because you have similar liking system, and then use that to determine what should be the recommendation based on what your best friends offer. So in this case, the notion of similarity very important. Item similarity means distance between the items. That is basically, again, important to understand what is the similarity. Where did we see the similarity function earlier? In clustering, where you saw similar data in groups. So distance function plays a very important role. Here in user-based filtering, it's about distance between users. Similar user as the current user. In case of items, it's about between items, current item set and what earlier items you have done. So both cases, it's about distance function. So you need to be very clear that a lot of times recommendation systems technically governed by this collaborative filtering techniques based on distance function, which says that either have user-based collaborative filtering or item-based collaborative. Okay. So now look at one important problem which world was tackling with. When people were trying to working with images or text or audio, it was unstructured data. So what used to happen is, if you have to apply a regression or a classification or a clustering or a association rule mining or a recommendation system, you have to convert them into tabular data. Like for example, if you have an image like this of different cars, right? You'd have to convert it into some kind of a columns. Like what's the color of the car? Is it a racing car? Is it a diesel car? Is it or a petrol car? Or is there a history of how many races it has taken part? Like that, you'll create columns, and then the data will be like for each car, you'll have one row of data. So that when created, when goes into the actual training of the model. So what happens is directly you cannot work with the image. And that is where the concept of deep learning came up. Deep learning said, why do I need to work with artificial features from raw data and then apply ML? Instead, can I not directly apply input data and apply a classification? And that is where the concept of neural networks based deep learning came up. The idea is that you don't have to, again, have intermediate layer of features. Like I said, right? Features means there's a racing car or something. Instead of that, you directly work with image, directly work with audio. And that became a huge boost to AI from 2012 onwards, where you started seeing applications like cancer detection, defective part detection, based on images, based on audio, based on text. Today, you're spam filtering on text. You have today image based on which driverless cars are there. All that is based on this deep learning, which avoids the concept of indirectly converting input images, etc., to features. So, but you see what happens in deep learning? You are allowing unsupervised learning of these hierarchical feature representations automatically. So what does this do? They do not learn like tabular features of the data, but instead they learn a hierarchy of features. So like, for example, if you have this image of a car, So next level will be some edges. From the edges collecting, they'll collect parts like this is the headlight, this is the bulb, this is the bonnet, like that. Then they'll create this is the symbol of the car. So there will be a hierarchy of patterns. So what deep learning does is from the image automatically create a pattern hierarchy without the need for you creating an artificial features set, which is like this. Okay. So what happens in this case? We need to look at creating a appropriate mechanism for identifying why this kind of a deep learning will be useful for unstructured data. Okay. So when we talk about deep learning, we're allowed to create hierarchy of feature representations without the need for converting input data into images. So as you can see, deep learning is still doing classification, clustering, but it's not based on any kind of raw data as we can see. Okay. So what I want to do now is I want to do a small exercise and then we will discuss. So I want you to take a notepad and take this small quiz. We'll come back and discuss. Okay. So this is what I'll give you 10 minutes. Don't please give answers. So what I'm going to do is, let us say I have these scenarios. These are industrial IoT scenarios. I've showed you 10 different AI scenarios. I said you can have generative AI, where you're synthesizing things, or you can have supervised with regression, continuous output, or supervised classification, where you're categorizing data, or you have unsupervised scenarios for a clustering, grouping similar data, or you can have anomaly detection, detecting unusual data, or reinforcement learning, where you don't have historical data, where you're learning from experience. Or you can have association rule mining, where from raw data you're finding co-occurring data, where you buy this, you buy that. Co-occurring. Or you can have collaborative filtering, either user-based, means you're talking about something where you're depending based on similar users. Or you can talk about item-based collaborative filtering, where you talk about, you have similar data items and then recommend based on similarity of the items. But lastly, you said that, oh, I may have scenario where I'll deal with images. I'll deal with data where I don't convert it into actual tabular data before applying ML. So I may actually want to do something called as feature extraction. So is it clear? So I want you to, on your own notepad, please match what is the best. For A, what is best? Is it 1, 2, 3, 4, 9, 10? Which one? B, what is it? Then like that from A to I, please do this. And then in 10 minutes, we'll come back and discuss. I want to take this exercise. This is part of the workshop. So can I take a poll? How many of you are okay to do this?
Yes, sir.
No, what is the whole point of learning? It's not about feedback. It's about learning, right?
Yes. Okay, sir.
Okay.
Okay.
So I'm assuming that you'll be going ahead and doing this. I did not get show of hands. Are you attentive? Or this is just,
Yes, sir. Yes, sir.
I'm not getting too many yeses on the chat. I want to see as many yeses.
Yes, sir.
Yes, sir.
Otherwise, there's no point in this workshop. It's just putting attendance and done. I'm wanting you to learn. Okay, please do that. Okay, fine. Okay, so I'll give you 10 minutes and after that we'll discuss.
Sir, your voice is not audible. Please check, sir.
Am
Now
I supposed to
break.
speak? Am I supposed to speak? I've given you an assignment.
Yes, sir. Yes, sir.
So what does it mean that my voice is required? There is no sound because I have asked all of you to do an exercise. So I hope that is the issue. You're not attentive. So
Sir, participants are doing, sir.
where I'm getting feedback on the chat saying that there's no sound. That means they are totally,
Yes.
absolutely not attentive.
Yes,
What
dear
is the purpose of
participants,
doing?
kindly do the case studies, please. Please respond.
No, I'm waiting for 10 minutes. I'll give you 10 minutes. In next 2 minutes, in next 5 minutes, I'll start discussing. It's in your interest to do this. That's what I'm saying. If you're learning,
Please.
if you're not putting, you've gone somewhere without attending and then come back and say that not listening, not having audio, that means that you're practically not interested in the workshop. As senior people, that's not expected, right? As senior faculty members who are coming with so much effort, it's important to make value, take value from.
Yes.
In 2 minutes, we'll discuss. Please try to wrap up so that you have an idea to validate against what I am going to present.
Yes.
So what we'll do is we'll put the answers, then we can match. Don't worry putting answers right now. You can verify yourself, but what we'll do is in 2 minutes time, I'll put the answers and then we can debate. Another 1 minute time, I'll put it up. In the meantime, you please try. I'll try to put some, but we'll do a debate. Okay. So what I'm going to do is I'm going to now basically try to put what I felt, and we can also debate. It's not like we have a very strict thing there. Okay. So what I'm going to do is I'm going to take this and then put it there so that it becomes easier for us to match. Okay. So let's look at each one. The first one, where it says that you're observing the best value at each step so that over a cumulative one, right, real-time pressure readings, you can minimize the overall power loss. That means you're learning from every step. So this is basically what we do in reinforcement learning. So in reinforcement learning, the idea is that we try to learn from each iteration, as you saw that. So those of you who got reinforcement learning, great. I hope you got it. Basically, you're trying to observe each step and trying to improve. So what you need to do is you need to create a scenario of automatically learning from every step so that overall you try to minimize the power loss. So that's why it is reinforcement learning. Okay. Any questions on that? Okay. So let's look at the second one. You want to alert engineers when a machine's vibration suddenly deviates from normal readings, even if it does not completely fade. That means there are some normal readings and suddenly vibration is having unusual spike or something, right? So what happens in that case? A potential anomaly means it's unusual. It's not a normal reading, abnormal, right? That's why it's called as anomaly detection. So key is to understand the wording, the way you look at the industrial AI scenario. So you say that vibration is suddenly very high or very low compared to the normal readings. That means it is unusual. It's not following the normal pattern. So that's why it is anomaly detection. I hope it's clear. Any questions? Okay. So note the way you try to apply AI, even though you have tools, but you need to know what kind of modeling of AI should be done for that particular scenario. One thing I want to tell you, I actually don't have all the 10 scenarios. So generative AI scenario is missing. So in case somebody thought in generative AI, it's not there in this. Though I gave 10 options, but I only gave 9. Okay. So I hope it's clear why it is anomaly detection, because it's talking about deviation from normal. See the wordings. And this is a hardcore industrial AI scenario. I'm not talking about something which is, from thin air. Let's look at next one. You look at grouping thousands of machines based on similar maintenance characteristics, how you looked at RPM, historical temperature. The moment you say grouping of thousands of similar data, it is clustering, right? So fairly simple wording. But you need to understand that sometimes people may want to use words like segment. They may not want to say that similar grouping. They may want to say, I'll segment the data. So it's not necessarily that always it is going to be used as, a wording like grouping. So you may get sometimes words like segmenting. Okay. So let's look at the next one, where you want to estimate a variable, flow rate. It's a continuous number by having pump speed, pressure, and flow history as the input. Based on that, you'll determine what is the flow rate. So that's the number, numeric output you're predicting. So naturally, that will be a supervised regression. Right? I hope you got that. Why it is supervised regression? Because we're talking about creating an output value estimation. Wherever you want to estimate, it's always a regression. So you need to understand the words. Typically, when you say regression, it will be basically tries to look at the kind of output variable. Is it a continuous variable? Here you are estimating a flow rate. Okay. The next one is very simple, very, very simple, because I only given there are only 3 categories. And also I've used the word classify. I should have used categorize or something, right? So basically what I'm saying is, is the motor condition normal? Is it overheated? Or is it failing? Based on sensor inputs. So I have 3 categories: fixed output, fixed number of output classes. So naturally it is supervised classification. Okay. The next one you say, what I'm saying is, when you have, pressure spike and chemical leak together, that means these occur together. So 2 sensors which are related to both will be usually they spike together. When one goes up, pressure spike happens, chemical leak also happens. That means they're co-occurring. That is basically what is market basket analysis or associative rule mining. If X is bought, you also buy Y. So here when pressure spike occurs, chemical leak also happens. So that means that they are concomitant. Or rule mining is primarily to say that I want to create a scenario where I'll identify if one occurs, the other occurs simultaneously, co-occurring relationship, right? So you see here, what you need to understand is that it is not necessary for you to create a scenario of knowing only one. You can also learn what is the corresponding co-occurring symptoms. So if you identify one, you can identify the other also. Okay, so let's look at the next one, where I hope co-occurrence is clear, because it's talking about an association. When pressure spike occurs, chemical leak also happens. So it is like co-occurrence. When one occurs, the other occurs. The next one is talking about learning something from sound recordings. It's unstructured data, sound, audio, video. That is basically where you're talking about unstructured data directly being passed into learning. So that is why it is deep learning based feature extraction. Same way, you could have something like taking a look at maybe the graphs of the vibrations, if you look at images of that, and then learn from that. That could also be a deep learning, because you are trying to talk about creating a pattern from directly the unstructured data without having to go through the manual process of converting into features, right? Then let's look at this. Let's say you're talking about predictions influenced by machines with similar to represent replacement parts. So yeah, you can say this is user based because you're talking about similar users. So in the case of machines, it's about similar machines, but it is basically saying that if you look at commonality of the way machines are categorized, they're falling under similar. So here there is a bit of confusion. Sometimes it can be considered as user or item because we're talking about machines, but the way they're looking at is the idea of different machines who are of similar taste, similar user of similar taste. That's why user is most appropriate. Whereas in I, what we're doing is based on type of parts in, let's say, one machine, you're looking at similar spare parts. So you're trying to look at, for this part, what are the similar parts to this. That is why it is item-based collaborative filtering. Though there can be confusion. Sometimes you may want to view this because we're talking about similar machines. So I would say there is definitely, I would give equal marks to both user and item in this case. But I is definitely item based because you're talking about similar spare parts. But in case of H, because you're talking about machines of similar type, similar to users of similar type, it's more user. But if you say somebody as like machine engineer who is operating on similar machines, then it could be considered as item based. So there is that kind of a confusion sometimes there. But broadly, if you see, the important thing you got to understand is you're trying to find for one user, in this case, one category machine, you're trying to find similar spare parts. That is why it is item based. Whereas in this case, the machine itself, you're trying to find similar likes. That's similar to the user based. So that is the fine distinction. Okay. So what I want to conclude is saying that the idea of AI as applied to industrial IoT is about identifying what is the type of AI. So you may ask, I may not have any scenario of generative AI. Now I can think about scenario of, like, for example, for identifying a defect detection. I don't have enough defect samples of images. So I'll generate a lot of defect samples. That could be a generative AI use case, right? I just completed the whole thing. Okay. So thanks for this opportunity. And I hope you had some learnings from this. Thank you.
Yes, sir. Thank you, sir. A very good evening to everyone. On behalf of our institution and the organizing committee, I am honored to propose the vote of thanks to Dr. Srinivas Padmabhumi, sir. Sir, thanks for today's insightful session on AI models for Industry 4.0. So first, I extend our heartfelt gratitude to our esteemed resource person, Dr. Srinivas Padmabhumi, sir, for delivering such a comprehensive and thought-provoking presentation. Sorry. For delivering such a comprehensive and thought-provoking presentation, your session has given us a clear understanding of how AI models are transforming Industry 4.0 from automation and predictive maintenance to intelligent decision making and smart manufacturing. The practical examples, case studies, and real time applications you shared have truly broadened our perspective and deepened our knowledge. I also wish to thank all the participants for their active participation and cooperation throughout the session. Your involvement added great value to the program. Once again, thank you, sir, for enriching us with your expertise and for making this session a memorable learning experience. Thank you very much, sir. Have a great day.
Thank you.
Thank you, sir.
And
Thank you
wish you
so
all the
much.
best.
The session was excellent, very informative. So, use cases are really thank you, participant, for doing the assignment. Thank you. Thank you, sir. Thank you very much, sir. Srinivas, sir, have you joined? So, participants, please wait for 1 minute. Next speaker is going to join.
Yes, madam. Mohana, madam, I have joined.
Join, sir?
Yeah.
Yes, sir. Okay, good evening, sir. Good evening, sir. Srinivas, sir.
Good evening, madam.
It gives me great pleasure to introduce our esteemed resource person, Dr. K. Srinivas Rao, sir. Dr. K. Srinivas Rao, sir, was born in AP, India. He received Masters in Microelectronics from Central University and MTech in Microelectronics and VLSI from BITS Pilani. PhD degree in Microelectronics from Central University and postdoctoral research in VLSI from University of Salento, Italy. He is presently working as a professor and additional HOD, Department of Electronics and Communication Engineering in Koneru Lakshmi Education Foundation, deemed to be University, Guntur, AP, India. So his current research areas are MOSFET, FinFET, SRAM, DRAM, low noise amplifiers, nanoscale semiconductor devices, MEMS-based reconfigurable antennas, MEMS actuators, RF MEMS switches, RF MEMS filters, etc. He received Young Scientist Award from Department of Science and Technology, Government of India in 2011. He has also received UGC Major Research Project from Government of India in 2012. He received Early Career Research Award from SIR, Government of India in 2016. He has published more than 21 IEEE transactions journals. He has published more than 264 plus international research publications and presented more than 75 conference technical papers around the world. He has published 6 books as editor and 4 patents. So he has more than 2000 citations and H index is around 25 and I-10 index is around 19. He is the he is a member of IETE, ISTE, IEEE. He is Best Teacher Award 3 times in KLU. He has organized 1 international conference and 20 national workshops and 10 international FDPs and national FDPs. Each one is partially funded by SERB, ISRO, etc. So 10 PhD research scholars has been awarded under his guidelines and 6 PhD scholars are working with him. He is a reviewer for many SCI indexed journals like IEEE Transaction, Elsewhere, IET, Springer, etc. And also external reviewer for many universities for MTech and PhD programs. I welcome you, sir, for today's session. So take over the session, sir. Srinivas, sir.
Yeah. Thank you, madam. Thank you. I think I am audible to all of you.
Yes, sir. Audible, sir.
I am sharing my presentation. My screen is visible, madam?
Yes, sir.
Yes, sir.
Okay. So I think it is in full screen mode and it is changing the slides also.
Yes, sir.
Okay. Thank you, madam. So thank you, madam, Dr. Mohana, madam. Thank you for the opportunity. Good evening to all the participants who are presented here. I'm K. Srinivas Rao, currently working in KL University. So I'm the background of electronics and communications, and I'm working in the research area where some machine learning and artificial intelligence techniques I have been used for the some nanoscale devices. So in this connection, so this is an overview. This is an overview of the machine learning and artificial neural network. So this is the contents of my presentations. First, I would like to give the briefing about machine learning and why machine learning is required and what exactly is machine learning and how does a machine learning works and what are the types of the machine learnings and examples of each machine learning techniques and also few algorithms of the machine learning and then some what is the difference and differentiation between the machine learning and deep learning and machine learning and artificial intelligence. And finally, I will also show you the applications of machine learning. In addition to that, I will also touch the artificial intelligence and its applications. So overall, this next 1 hour and 15 minutes is going to be move around mostly on the machine learning and artificial neural network, artificial intelligence. In addition to that, I would like to also show you last 15 minutes is about my research activities, what we are doing at Kale University in the name of the Computational Research Lab, which is also called as a microelectronics and computational lab. What facilities we have, what we are doing, and what we achieved so far, and all. So this is a very great platform for me to share my experience in my research areas as well as in the area of the machine learning and artificial intelligence. And I request all the participants, please treat this is a very basic level of understanding of machine learning, perspectives, and artificial intelligence towards the research application or the research problem solving. So let us understand what exactly the meaning of the machine learning. So what people, the great people says about machine learning, because there are many definitions are there. Many people says the meaning of the machine learning in different ways. But the way I understood, I would like to share with you. So one of the person who has defined the machine learning is the Herbert Simo, and long back he has defined what machine learning is something like it is the learning, it is something like a learning, and it is a process of learning by which where the system improves its performance and system improves its performance from its experience. So that is the great definition said by the Simo, and this definition is slightly deviated when person to person and textbook to the other textbook the meaning, but whatever it is, so machine learning is something like a process where the system should improve its performance by its experience. And he is the man who stated this statement long back, and still this statement have some sense. And also in addition to him, there's a Tom, and 1998, he said machine learning definition in a different perspectives, what he understood and what he practiced. He says that it is the study or it is a study of algorithms, a group of algorithms to improve their performance to attempt some task with an experience. So that way, machine learning can be defined with the functioning of P, T, and E, performance, some task handling, and then by experience. So by this, what one can understand is that machine learning is the process of doing the system improvement by its experience when we apply the modeling. So that way, these two definitions have a great meaning, and it doesn't change the meaning of the machine learning. But we are nowadays we are seeing so many other definitions also, whatever it is. So the meaning of the machine learning is something like this. And we can say broadly, the machine learning is a branch of computer science. We can say machine learning is a branch of artificial intelligence, and where we can construct and where we can study the systems that we can learn from the data. So we have already a data, we will learn from the data. And machine learning can empower the computers to learn and behave more intelligently. And also machine learning explore the algorithms, build certain models, different kind of the models. Those models learn from the data, those models use the for predictions and use for decision making as well as to solve the problems. So machine learning will explore different kind of the algorithms. So there are different algorithms are there, supervised algorithms, unsupervised algorithms, and reinforcement algorithms are there. But all are from the meaning of learn from the data and use the model, predict the data, decision, and also solving the problem. So in this direction, machine learning will use different researchers in the research point of view. Machine learning is not a part of any particular domain. It is a interdisciplinary, and we can say that this is having a lot of applications in all the engineerings, not only in specific only one industry or a specific to one particular branch. It is having the multiple applications. So generally, what we do, the traditional programming is a computer. What it will do, a computer program will take the data, and there is some program, developed program is there. Based on the that program, the intake data will process it, and we will get the output. That is actually usually a conventional or a traditional programming. Whatever the programming we say and we do, this is the normal procedure. But where machine learning is quite opposite to this. It is also do with the help of the computer, but the computer will take the data, and the computer also will have some output, and based on that the computer will develop the program. So that program will help us to predict our data as well as to solve the problem and from the data. So here the data will play a very important role. Huge data we have. When we huge data we have, the predictions are going to be a very complicated. So in this direction, when do we use the machine learning? So machine learning can be used whenever or wherever human expert alone doesn't exist, where we can see the navigating on Mars, and also human cannot explain their expertise like a speech recognition, and also models cannot be customized like a personalized medicines, and also models are based on huge amount of the data. So in all these four ways or different directions, you can see here navigation on Mars and speech recognitions and personalized medicine and also the genomics. So in these all the ways where we require the machine learning, because here the machine learning algorithms will solve the problem. So that is called the learning of that particular data. So we have a data, we'll take the data, we'll learn the data, and the data can be processed it, and finally we will predict the some sort of the outcome. So learning, it doesn't always it is not only always useful. So we have to always learn to model and learn to be calculated. So whatever we have the data to be modeled, how you are modeling, how you are customizing, how you are going to use the model to solve the problem is really a meaningful algorithm. So in this way, so machine learning is, we can say that it is a part of the artificial intelligence, because artificial intelligence is the branch where machine learning is a subset of the artificial intelligence, and deep learning is a subset of the machine learning, and this machine learning, deep learning is a part of the artificial intelligence. And overall all these three, machine learning, deep learning, and artificial intelligence, from the data analysis we have a data science. So this way, one have an expertise in machine learning should also must know the what is artificial intelligence and the deep learning. So artificial intelligence generally develop the computer systems. Those are able to perform the task. Normally, they require the human intelligence for that problem, solving the problems. Whereas coming to the machine learning, it have a computers that will have the ability to learn. So whatever the computer we choose that have the ability to learn from the data, and that is being explicitly programmed, and therefore the problem can be solved. Whereas coming to the deep learning, different kind of the machine learning algorithms with the brain like logical thinking and some mathematical logic expressions will be used to structure the algorithms. Therefore neural network will play a very important role here. So all these are an interlinked and one depends on the other. Therefore, any kind of the problem can be solved by using of these domains. So one particular example, you take a classic example of the task that is required machine learning algorithm. So here we can say different numbers we have. So it is very hard to say what makes two here. So there are numbers are there, but from this group of numbers, it is very difficult to recognize as well as the separate the number of two. So here we require the machine learning as well. We can also see the some other kind of the algorithms. What type of the algorithms are used to solve the problems are, one is recognized patterns, where we use the facial identifiers and facial expressions and handwritten and spoken words recognition and medical images. In these all these ways, we require the recognized pattern point of view, some algorithms, and recognizing anomalies. And here unusually we credit card transactions are there, and also unusual patterns of sensor readings from different industries. All these anomalies recognizing point of view, we also need the algorithms. And also we have a generic patterns, the images or the motioning of motion images, the capturing of those images sequences and all, we have a generic patterns. And finally we have a predictions, that is the future the stock prices are currently exchanging rates. In all these ways we need different learning algorithms. Using of those algorithms, the best way of solving the problems in different areas, where web searching, we have a different kind of the algorithms which already developed, and also computational biology point of view, so to identify the cell size and also the nature of the cell, like we have a lot of biological issues in the human body, like let us say cancer. So early stage detection of the cancer, early stage detection of the breast cancer is one of the highest challenging task in the research, where nowadays the machine learning is highly used for those type of the problems, where one of the a small piece of that particular research problem we are handling in our research lab also. So what we usually do is that there is a sensor for the sensing of any kind of the biological substance, right? So that should be a portable, and that should be highly sensitive, and that should be highly accurate results should be come out. So what we do is we develop the machine learning techniques, we develop the algorithms, already existing algorithms which are suitable for these sensors, and we take the data from the sensor, real-time data from the sensor, small data, and from the data we will use the models, and we will generate the huge data out of it, and from the data we will optimize the sensor. So once we optimize the sensor, that is the best way to sense the any kind of the biological way. So, and also machine learning algorithms are there in the finance and e-commerce, space explorations. Nowadays, this is also another very good important area, where the aircrafts and also the flying of any objects can be captured, and it can be navigated properly. And also robotics, information extraction and social networks, debugging of the software, what not, everywhere you can favorite any area, everywhere these machine learning algorithms have been partially or fully implemented so far, at least one of the algorithms. So like that, machine learning has been developed and it has been improved. But what way we see this improvement in the market, what is really the real time experience we have in our daily life? Let us take one example. So one example is, let us take when we go to the grocery shop. Usually we do this particular real time exercise, right? We usually go to grocery shopping, and we do, before going to the market, we will calculate what type of items we want and what would be the approximate price and all. We will prepare one budget. So Now let us take this example. So let us always prepare the list of ingredients before going to the shop, and also make the decision according to the previous experience. We have already purchased several things previously, so definitely we could have some idea on the entire list of the ingredients, how much it would be, how much the total budget, and as well as the how much the volume of that particular ingredients, right? But this scenario is change every time we feel this experience. This time we go for some list of ingredients or list of items. Next time also, after a month or after a 2 months, after a 3 months, we go, we do some changes, we experience this, right? What happening, why the same kind of the items are changing, and how this is coming out. So whatever we purchase, items are same, but there is a inflations. It's not too easy to work out in the budget. So what we can observe is the budget get deviate a lot of times. So always we go with one kind of the budget, but it will be deviated from the previous experience, and the current budget is different and the previous budget is different. So this happened because shopkeeper changes the quantity as well as the price of the product very oftenly. So today we buy one product, and the cost of the product as well as the quantity of the product may not be the same next time whenever we buy the same product. Definitely not. So here, due to those factors and as well as the several other factors, I have to modify my shopping list. So what I can do, I have to put a lot of effort, I have to do a lot of research on it, and I have to spend a lot of time to update my list of every change before going to the shop, or from the previous experience. So it creates a lot of uneasiness. It's a something like I used to confuse about what to do and what not to do. So here, where exactly the machine learning coming to the rescue. So let us see, if you're still confused, let us see and how we can use how we are using the machine learning here for this particular exercise. So let us go deep inside into understanding of the machine learning techniques which is applying here. Okay, so what we do is that machine learning, it's something like a technique, a popular technique, which is going to be predicting the future and classifying the information which comes from the previous experience, that help the people to making a necessary decisions. So that's why machine learning algorithms are trained over different examples through which they learn from past experience, and also they analyze the data of the previous one, that is called historical data. So here we can see the machine learning is something showing here. 1 minute. Yeah. So here we have a system. That system will have the data, and that is having with the artificial intelligence, that may be any kind of the machine learning. And what this machine learning will do is that it will learn the data from the existing data, and it will predict it, and surely it will analyze the data. So that way, this machine learning is using to understand the data as well as to predict the data, which is going to be an exact mechanism for the understanding of machine learning. My slide is changing.
Yes, sir.
Yeah.
Yes, sir.
Yes.
I am stuck in my system. Yeah. So what we can say here, we train our different examples again and again. We used to apply the machine learning to identify the patterns in order to make the predictions, and those predictions will help you to understand the futuristic data. So with the help of this machine learning, we can also develop the intelligent systems. Those are capable of taking the decision, and which is autonomous basis. Like we can say that we can do this intelligence, like problem solving and perception, learning and reasoning, and also more intelligently. So all these algorithms from the past data through the statistical analysis or the pattern recognitions, everything is depends upon the data. So that is the learned data. It provides you the predicted values, it products you the predicted results. So data is going to be the backbone of any machine learning algorithm. Whatever the algorithm you take, the data is the main hardcore, and from the data, whatever we do exercise, whatever we do the analysis, whatever we do apply the modeling, anything can be done. But data is required, and data has to be uh, help you to provide you the futuristic predictions. So with the help of the previous historic data, we are able to create more data from the training, as well as we can also go for the testing these machine learning algorithms. So
Sir,
as all
Srinivas
these,
sir, sir,
yes,
sorry to disturb you, sir. Sir, please kindly erase the some. You have written something
yeah,
in
yeah.
screen.
Yes, yes.
Thank you, sir.
Yes. So from these previous data, we can have the predictions of the historical data to predict it. In this process, we have a generic algorithm and generic artificial neural network we have. And this is an advanced concept of the machine learning, where here completely learning from the previous images, which are capable of generating more and more future images. So here we can see some of the real images here, and we have the generator here, neural network generator, and it generates the some phases, and any kind of the discriminations are happened here from this neural network algorithm, and there is a fake or it is a real algorithm. So here the previous data will help you to generate a new images. So this is also applicable for the speech as well as for the text, not only for the images, it will also use it for the speech and the text. So the machine learning opens a vast potentiality for the data science applications, particularly the people with the help of with the background of computer science, mathematics, and statistics, and a computer science with the help of the mathematician, a computer science with the help of the statistical person is going to be a creator in the field of the research, because modeling will help you to understand very easily from the algorithms. So algorithms is already developed, but there is a n number of possibilities are there to change the algorithm, to do the modification of the algorithm based on the mathematical modeling. So that's why the statistics is an essential component for the drawing of interfaces from the data. Whatever the data we have, from the data, the statistics will have an essential element which will do the best way of the processing. And also the mathematical mathematicians is useful for the developing of new kind of the machine learning algorithms, and simple models is not enough sometimes to solve the problems where we need to optimize the model, otherwise accurate results cannot be obtained. In this process, optimization techniques also be involved. When optimization techniques are involved, there is a hyperparameters. The hyperparameters has to be tuned to reach the optimum results. So in one particular machine learning model, there are n number of elements are involved, n number of components are involved, where we have to be satisfy all these components finally to bring out the best machine learning algorithm, and also for each problem. So machine learning is in every domain, and it is being is impart intelligence to the static systems. And now whatever we are going to be use this machine learning for the models, that domain is an appropriated for the systems. So here why we go for the machine learning, because we are in a need of the uh, um, um, today world we are having some requirement of the people, and the fourth industry revolution of the data is there. We have a data, the data has to be perform well and get it experience from that, and to be produce the more and more data from a small data. So in order to derive such a kind of the meaningful insights from a small data to the huge data, so the way in which people and the system interface with the data, so both all these ways, data and the person has to be interfere, and also it has to be provided with the system. So always industry like biomedical and healthcare, particularly the and banking systems and other industries, machine learning is becoming one of the essential part of the industry. Otherwise there are many things has to be go down, and now whatever the biomedical as well as the healthcare industries as well as the manufacturing industries and banking system, all are now incorporated different kind of the machine learning techniques into their industry to solve the problems and to reduce the time for the processing. So in this direction, what we have understand and realized, data is powerful, and in order to harness of the data, we need a computational power, that is the machine learning, to be added to in a different dimensions. The way we see the perception information is different. So machine learning is being utilized everywhere, where in electronic industry particularly we see the way the wristwatch, laptops, and also the physioelectric shoes, which will always continuously monitor the human body of all organs continuously. Today we are seeing one of the popular smart sensor in the electronic industry is, even you are sleeping, your heart pulse as well as your blood as well as your some of the kidney, some of the other organs like kidneys and all, how these are functioning can be monitored continuously in the display of a smart device, because there are several sensors are embedded inside in the system, and those are continuously getting the data. And even though you're sleeping, after getting up you can see that how your all organs are functioning from evening 10 o'clock to morning 6 o'clock, and what are the changes are happening at what time, and early morning what is happening, and in midnight what is happening, and accordingly people are going for the approaching of the doctors at different stages. But here the point is that all these devices are adapted the smartness. So the smartness means the powerful machine learning algorithms have been utilized in the electronic devices to getting the data and processing the data and also the predicting the data. That is what. So electronic devices, what we use, the applications that is a part of in our everyday life. Without those devices, even we cannot run our day effectively. And also we can see the machine learning in the Google, so which is a very popular one, is able to provide you an appropriate search results based on the browsing of habits. Based on your habits only, you will get a connectivity data, as well as Netflix, which is also another capable of recommending the search for the entertainment point of view. And all these are based on your previous data, the search will be followed. So machine learning will facilitate an automation of redundant tasks, so that taken away from the need of a manual labor. And all these are possible only due to the massive amount of the data that you generate on daily basis, and that always facilitates several methods to make sense of this data, and that will provide you the study fast and accurate results. So in this way, the machine learning algorithms as well as the machine learning techniques we used in our daily life with the different applications. So how does this machine learning works? So what is happening? We have a data, input data. So how this data is going to be analyzed, how this data is going to be predict, how this data is going to be stored, and then take the feedback of the data and future using of algorithm, how it depends upon the previous one. So this is a continuous mechanism where we always exponentially increase the data. So there is a need of having a system that can handle this massive load of data. Any particular problem you take, and as you are doing research, then take the data. And as you are taking the data, you need a data, and more data you need. So the more and more data you have, then you have a constructive measurement of that particular problem or solving the particular problem. So where the machine learning models like a deep learning and other kind of the models will allow a vast majority of the data to be handled with an accurate generation of predictions. So those massive data handling accurate results, that created a revolutionary the way we pursue information and various insights we gain out of it. So one example you take in our research problems, that may be any kind of your problem. Let us take. So I am taking in my point of view. I have a one sensor. My sensor I have designed for the purpose of problem solving. So initially I have designed that sensor. So I have some data. So that data I have used for machine learning. The machine learning use the data and generate huge data, and that huge data will help me to understand that particular sensor. So once I understand that particular sensor, then I can able to understand how the sensor is going to be work out. So once I understand the sensor, how this is going to be work out, the sensor will have several parameters to perform its way. So all these insights we will gain from the pursue information, the way we see and the way we generate the data. So like this, there are many machine learning algorithms are there. There are majority of the machine learnings are the three types: supervised learning, unsupervised learning, and reinforcement learning. So all are not for the same cause, and all are not for the same purpose of the problem solving. And supervised learning is learning. Machines learn from the training data. Data is main role here, and unsupervised learning is no training data is required, and reinforcement is machines learn on its own. So all these three ways, whereas supervised, unsupervised, and reinforcement, all the three cases, data is a key player. So in a supervised learning machine learning, again we have a classifications. In that, popular one is the classification supervised learning algorithms and the recreation learning algorithm. And classification algorithms are mostly used for diagnostics of the purpose of the data and customer retention purpose, and identify the fraud detections purpose, and image classification purpose. This is used, and basically it is for the classifications. And the recreation of the machine learning supervised algorithm is to estimate the life and market forecasting, weather forecasting, and predicting of popularity and population growth predictions, and etc. So these are required small data. From the small data, this is going to be supervised, and it is going to be solve the problems of all these different areas. And unsupervised is something like feature extractions, and structure discovery, and meaningful compression, and big data visualization. So all these are the dimensionality reduction point of view. Whereas we have a clustering also in unsupervised. We have no data here, but it is going to be train it. And here the customer segmentations and market targeting and the recommended systems, these are comes under the category of the unsupervised learning. And the third category is the reinforcement learning, is the game AI skill equations, learning task, and robot navigation, and real-time decisions. So this is no data is required for this. So in a broader way, the classifications of the supervised, unsupervised, reinforcement learning, machine learning algorithm is dimensionality reduction and clustering, and reinforcement is something like robot navigations and gaming and finance sections. All these different category of the algorithms are going to be solve the problems in the field of finance, in the field of the banking, in the field of the sports, in the field of the healthcare, in the field of the industry, in the field of the electronics, in the field of the different engineering, so we can say. So in this way, let us see the supervised learning algorithm. Supervised learning algorithm, as we mentioned, that the data sets on which we train our model, that is called the label. We can see here from this above figure, we have a labeled data, and we have a machine learning here, and for that machine learning we have developed a model, and this model is going to be tested the predictions of those data. So the data we have here, form of these circles and rectangular, triangle, and trapezoidal, something kind of the labels we have: rectangle, circle, triangle, hexagonal. We have those are the labels, and there is a clear and a distinct mapping of input and output data here. And here, input, the model is able to get the trained in the instance where it's a functioning of mapping with an input to an output, which is supported with both the pairs. So we can say that all these labeled data is given to the machine learning model. The machine learning model will train this data and will predict it. That outcome will be segregate, will be classify the kind of the label it is. So based on the labeled data only, the machine learning algorithm is able to determine. Otherwise, if the data is spam or harm, this is an easier form of training. And that way, we have a spam filter workout. So emails we used to see in our inbox in from the different mails like a Gmail, Rediff mail, Hotmail, and also personal institutions, educations, institutions email. And from this, we have any emails, and there is a machine learning technique algorithm is applied to that. And if the email is spam, so that is the criteria one, if there is any contained or not. Criteria two is the sender is a particular sender or not. Criteria three, sender and email interactions. So there is a filtering in this. Based on the filters, the email and inbox, and if these are not comes under this category, it goes to the spam and spam folder. So that spam filtering is an example, this type of the machine learning algorithm, because what algorithm is used here is the criteria one, criteria two, criteria three. Based on that, this is going to be the filter the emails. This is also a one of the advancements in the email checking. So all mails we cannot see always, right? Some mails automatically go to the spam if you select the filtering of that particular. Until unless if the sender is a person from institution or a person from individuals, then it will be take that is your unread data. Otherwise, remaining advertisements, remaining so many other kind of the business type of the emails will goes into this spam category. So unsupervised learning, because here in the supervised learning we need to understand is the data, labeled data, that is going to be a base for us, and based on that we are going to be segregate. And unsupervised learning, we here is the user do not get any supervise the model. So because basically pattern and knowledge that was previously undetected. So it deals with unlabeled data. There is no any labeled, there is no labeled data. So when there is no labeled data, the algorithms are identify the pattern within the data sets and learns from the data sets. Once that learn from the data and the data into various clusters based on the density, then based on that one can able to perform the visualization on higher dimensional data. So what is happening, you have a raw data and the data is given to the algorithm, unsupervised algorithm, that is called unlabeled data, and that unlabeled data is going to be make some kind of the various cluster based on density, and that is going to be predict the outcomes. So that way the unsupervised learning will do the exercise. So here we take the example of the unsupervised learning. So unsupervised learning is a type of the machine learning where algorithms learn from unlabeled data and without any prediction outcome or targets. So here you see we have a raw data, so we don't define any particular type of the data. You have all kind of the data here. So interpretation we have, and we have used the algorithms, and then we process it, and from the processing we have a outcome. In the outcome of the data also we have a data. So that is that way we will train the data and predict it. And in this way we have a one of the popular one is the k-means clustering. Is type of the unsupervised learning where data will be clustered, and from the cluster group of clusters it is going to be find out the patterns in the data and makes a meaningful model to predict the data. And also this k-map means clustering is another way, similar kind of the data based on the let us take here the persons of their height, their weight, and their other patterns. So after learning the patterns, the model will make the conclusion. So whatever it is, the closest possible paths, it will take the similar kind of the unlabeled data and will process it. And finally, the reinforcement learning is one of the out of three, one of the basic machine learning algorithm, where here alongside supervised and unsupervised learning, it is most popular machine learning algorithm, but it is mostly used for the autonomous systems like autonomous cars and industrial robots, where it works on its own. So it doesn't require any input data, it doesn't require any labeled data or unlabeled data. So basically it is a autonomous system. So the aim of this particular algorithms always to reach the goal in a dynamic environment where it reach based on several rewards and several inputs provided to the system. So what we can say, heavily used programming robots to perform the autonomous
Any
actions,
computer here, Ritvik?
and which will making the intelligent self-driving car. So self-driving cars we have in this second images, we can see this car will follow based on the second system. So one vehicle, one system is following the other system. So here the modeling is defined and modeled is formed in such a way that in a dynamic environment where the system will do on its own, that is called the autonomous vehicle, where no data is required. So similarly, the robot navigations also comes under the same category. So like this particular reinforcement learning algorithm is doing a lot of innovations in mechatronics as well as in the robotics, where autonomous systems are developing in a large scale. So in this process, if you have to see a particular machine learning approach like a recreation, so classification, so this is one of the three categories of the algorithms, where the recreation models are used extensively to predict the values based on the variables and as well as the depending upon the several factors. So if you really define the recreation models, and in that model, finally ultimate task is to predict the values. So there is a popular one is the linear regressions, and also we have a other type of the regressions are ARIMA, and this regression also is a very a popular one because autocorrelation regression is possible forecast continuous values. And also the stock prices and other values based on the time also this regression is used, and decision tree algorithms, which is also another one, and mainly to predictive the models. From that model we create the decision tree, and that is able to take the decisions. And both regressions as well as this decision tree that comes under the classifications, which is used always independent variables. Like that, many algorithms are there which will help you to understand the machine learning for different problem solving. So as we say that the machine learning and deep learning, machine learning is the knowledge analysis, and it's a branch of AI. And here we can learn from data, we identify the pattern and take the decisions. Whereas machine learning is a part of AI, which involves implementation of algorithms, which are able to learn from data or previous instance, and also perform the task. So always this is not a able to perform the task without any explicit instructions. We no need to give any kind of instructions. So this is a kind of a procedure where data is involved and statistical expressions are there, and those data is fitting into the models, and therefore there is a continuous evolution which will precisely provide you the results. But deep learning is something like a broader family of machine learning method, which is artificial neural networks and other models are used. In this learning, we have both supervised, semi-supervised, or unsupervised. We take any help. And deep learning is a part of machine learning because it involves usage of artificial neural networks. We can see here in the above picture, the machine learning, we have input, that is the car, and feature extractions and classification, and finally car or not car is the output. So from that classifications, we can extract it. And in the deep learning also, we can take the same example. We have a car as the input, and we have feature extraction plus classification is used as an algorithm, and finally we can predict this. So in both the ways, we have a predictions, but the ability of neural networks to learn from a large data more accurately. So that is a fetching point for the deep learning, and it provides the study fast results to the users. So it depends upon the problem to problem and area to area. People used to go for either machine learning or the deep learning. And coming to all these are under the umbrella of the artificial neural networks. It is the greater pool that contains more discussions on the technologies. Like you can say now, one machine learning is one stem of it, and we have natural language processing and computer vision, predictive analysis, and robotics. So all these are the artificial general intelligence, which is still far fetched, which is yet to become in a research to be utilized and moving forward. But there is still challenges are there in applications of AI. So if you see the developments of these artificial neural networks, machine learning, and deep learning, artificial intelligence are organized around in 1950s, machine learning in 1960s, and deep learning is 1970s. Today we are in 2025. So it was long back, quite almost all 50, 60 years back, the artificial intelligence and machine learning has been developed. In fact, it is introduced, and it is represented, AI represented simulated intelligence in machines, but machine learning is the practice of getting the machines to make decision without being programmed. Whereas deep learning is the process of artificial neural network to solve the complex problems. So very close, very close, the mechanism is there between the AI, ML, and the DL. And AI is a subset of data science, machine learning is a subset of AI and data science, deep learning is a subset of machine learning, AI, and data science. So ultimately all are under the comes subset of the data science, means data. So ultimately connected with the data. So the aim of artificial intelligence is to build machines which are capable of thinking like a humans, overall machines. Machine learning is aim is to make machines that machines learn through data so that they can solve the problems. And deep learning is aim is to build a neural network that are automatically discover patterns for the future detections. So it is completely autonomous. So ultimately, those three techniques of their aim is to build the machines, and accordingly they solve the problems. They have the capability of handling the problems, and so none of these are higher or more weight or less. More or less all are using in a at different stages. So the applications of the machine learning, if you see the prominent applications, healthcare, if you see what we have, we can uh, when we have the patients in the healthcare, like diagnosis the model, early stage disease like a cancer I have mentioned in the beginning, and the positive impact on the health of the patient and the healthcare system. So what is there here? It can diagnose, it can disease identified and medical care personalized and predictive medicine and medical images models, administrative workflow, drug deliveries, and medical documentation, etc., etc. So, of course, all algorithms may not be, but some of the algorithms. So, in this case, KNN you can take. So, KNN you can take, and decision tree algorithms you can take, and some of the algorithms you can take in a healthcare field to handle all this. So one of the important point here I want to mention from the research papers point of view, these algorithms. Suppose if you have a patient who is having the some kind of the diseases, so based on the several factors, we store the data of that particular patient. Suppose the patient of age, the patient of height, the patient of weight, and the patient of BMI, and the patient of other habits. We store the data because of those parameters. This particular disease has been identified. If suppose a new patient has come, so before going to the testing of that particular patient, these symptoms are also can be mapped to that patient and can be realized whether he or she can be close to that particular disease or not based on our previous data which is stored. So here machine learning will play an important role. So like that, this is one of the area, and finance is another area where we can use this machine learning in finance sections. For so many problems can be reduced in the field of finance, including creating, rating, frauding, and algorithmic trading, and also various anomaly activities, so which will be prevent unauthorized transactions. I like that security point of view, as well as the detecting the frauds and tech support, risk management, data analytics, several things. We have a sufficient machine learning, so that machine learning's algorithms in finance will optimize the decisions. So that is for the trading, that is for the risk management, that is for the investment. So these way it is used in another industry. And NLP. So NLP is another the area where machine learning is highlighted, where language translations and opinion mining and chatbots and text-based any data is processed in this context, and also for the emotions and the real-time responses like a smart assistant and a text summarization, predictive testing, and sentiment analysis, language translations, email filtering, and chatbots. All these are comes under the natural language processing, which is another area. And cyber security, where the malware detection, power system security, and spam detection. Here also we have an algorithm. So in all these areas where machine learning is directly and hugely used, in not only this, in many of in electronics also, I will also show you that. So based on that, what we can say that machine learning basics and how computer power has been evolved over the time to accommodate advanced machine learning algorithms. It is not new, it is the old, but the way we are understanding the computing the power will provide you a path to accommodate an advanced algorithms, and also computer gaining intelligence that is owing the data that is generated in the vast amount. So all these different type of machine learning algorithms is highly understandable and will be used for the handling of research problems. And the part of this is connected with the another one, that is the artificial neural networks. In this also we will briefly touch about uh, artificial intelligence, and what is this and where we see daily in our life. So we can say that world without artificial intelligence is something like a unbelievable. So life without technology is also unbelievable, and world without artificial intelligence is also unbelievable, because life without computer is unbelievable, life without technology is unbelievable, life without social interactions unbelievable, life without entertainment is unbelievable. Every day we need all these: health, medicine, everything. All these are directly or indirectly associated with the artificial intelligence. The way we see the time we spend on the social media, like in lifetime, like Twitter, Instagram, Snapchat, YouTube, Facebook, all are artificial neural network spaces. So 1 year 10 months, 1 year 7 months approximately, this is the survey as done in the research, one of the research paper. And the average time we are spending on the smartphones daily is taking photos for 3 minutes, and watching TV films are 7 minutes, like that, reading books, emails, text messaging, are all these. Finally, internet usage we are using for almost 0 to 24 hours. We are using mostly. So that way, if you see, 84% of the smartphones owners use the apps during their morning time routine for different purposes. Of course, all are for good cause, but whatever it is, but how the way we are using this artificial intelligence point of view, we have this research data from the research paper. So it realized that so without smartphone, difficult to run our daily life, and that smartphone without artificial intelligence, without machine learning, cannot be function properly. So what we can realize, so we go to our workspace every day, we go to our institution, either college or university or any workspace, whatever it is. So everywhere we see nowadays internet, and everywhere we see computers. So there should be a cloud computing. We can store the data, we have a scalability, we have good performance, we have easy backup, and we have a cost saving, we have unlimited storage, we have a cost saving, and 24 into 7 availabilities. Most of the workspaces use this cloud computing and other services for the part of this. So what it says answer to the, so how long and in how many books you will go for doing and reading and keep searching for the answer, like your any kind of research. So long back I was completed my PhD in 2009, so almost quite 16 years back. So that time I'm really saying that we don't have internet facility at that time. 2006 I started PhD, 5 I started at that time. We have, but limited sources we have. We don't have much laptops at that time, we don't have a Wi-Fi at that time. Very limited, very limited. So how we did our research? We did our research by reading papers. What papers we read? We download the papers and come and take the printout and read the paper and read the textbooks and all. From that we get the knowledge, what type of algorithm we can use, what type of algorithms they have used. But we are not up to the mark in literature because of resources. But now, today, as you are, if you are doing PhD or freshly completed PhD, you have huge data, you have huge facilities, all the facilities, all the facilities. Is a very simple. Just like that, you have your data, you have your resources, you have internet, you have algorithms. All these you can utilize and do your research and handling the problems. So you can also take another example, like you come back to home and decide to order the food online. So you are using again AI. So that is also another kind of app, and you are using artificial intelligence there. And before going to the sleep, also you have your this kind of the voice to text assistance that will be help you to make you to be wake up for the next day. All these stages, different platforms, directly or indirectly, knowing or unknowing, we are using artificial neural networks. Without artificial neural networks, we don't have this type of the facilities. So what I want to convey here is that we cannot imagine living without all that now what we have. Am I right? So that's why. So what is the meaning of artificial intelligence? So saying that it is an ability of computer to think and act like a humans, that is called human artificial intelligence. And some people used to be say that, and computers to think and act like a humans, that means like a robot. A robot, you take the robot has to do like what we do. robot has to do Robot has to say what we can say. Robot has to think what we can think. I'm thinking something in my mind, so only I can know, so you cannot know. In a similar way, a human mission has to be developed such a kind of the pattern and mechanism to be think, that is called artificial. For that we need to use several mechanisms, several algorithms, several mathematical modeling, and all. Of course, that is altogether different one. So it is the something like a imitation or cloning of human intelligence that allows machines, more specifically computers, to perform an extremely intelligent manner. So how it is possible? It is very difficult, because our memory, our storage of our memory, and the functioning of our memory is entirely different from the artificial neural network. So our memory chip is different. So what the engineering and science and technology saying that the computer will do extremely same kind of functioning like a human. For that, what is possible, they are applying on that. So we can also say the developing of computer systems can be perform the task like a human intelligence, such as learning. We also learn, that also learn. We also problem solving, they also do it. Decision making and pattern recognition. So from all these, the term artificial intelligence, coined in 1950s by John McCarthy. He is the man who considered the father of artificial intelligence still today in this world. So what he says is saying that there is a system, the development of a computer systems, those can handle or perform the task like a humans, either by learning, by problem solving, by decision making, or the pattern recognitions. That way, he defined the artificial intelligence is what exactly that is. And the need of artificial intelligence, so AI is science and technology engineering, making different kind of intelligent missions, and all those missions can be just like do what humans are doing. And basically we sometimes we humans are very lazy, because we love to live in this world. There is a minimum human labor, so that is always everybody looks for, to save our ample amount of time, because time is very precious. So the data what we are
Sir, are you
producing.
sharing the slides, sir?
Yes, madam, I am sharing.
So slides are not visible, sir. Just
Yeah, it is not changing.
no, sir.
What it is there?
So your name, designation details, and college name details.
No, madam. I have been moving on to the, I think in that. Is it now?
No, sir.
1 minute, madam. Is it changing now?
Yes, sir.
Yes, sir.
Yeah. So the need of artificial intelligence to save the ample amount of time, and for that, as a humans, we need do some process, and which is to minimize our time. For that, we need to handle the data. So how we are handling the data is the processing of data science. So we'll take the data, and the data has to be processed. In this way, the classification of artificial intelligence will be again weak AI and strong AI, because how the type of data you are taking, how you are managing that problem and solving the problem, based on that we have this strong and weak AI. So if you are handling only one problem, it is a single problem, then it is a weak AI. You are handling with a group of problems, then it is the strong AI, because multiple problems can be solved by the artificial intelligence. So all these, like we can say that a limited memory and reactive machines, theory of mind, and self-awareness. These are the some of the types of the artificial intelligence, where and when we have to use this intelligence to develop a systems or a computers to solve the problems. So after understanding of this artificial neural networks, it is uh, artificial intelligence, it is not only limited to one particular platform. It is also number of platforms, and in our daily life we can see in automobiles we use several apps to book our particular vehicle, and also to drop and pick up, and in engineering also to apply for different platforms, and gaming, healthcare, business, finance, government, and manufacturing. So in all the ways, the artificial neural networks is being used to handle the different platforms, and particularly it is also used in marketing and security, healthcare, transportation, life sciences, banking, and productive design. And also we can say that in a different perspectives: finance, education, business, automobile, manufacturing, gaming, government, and healthcare. So whatever the domain it is, all the domains what we face really in our daily life, all these domains are really required for people in the society. But let's understand what we can do and what we cannot do to apply this artificial intelligence, because multiple areas of our daily life. But is it any good? Does it really benefit us the way we being portrayed to, or the answers to this defines is yes, of course we are using, but understanding the advantages more specifically. So what artificial intelligence, whether it is having a less scope for errors, better decisions, can work for all type of problems, can be handled any type of problems, or it is utilizing proper resources or not, we need to know before applying or before going for the artificial intelligence. So examples of this artificial intelligence being used in our daily life is self-driving cars and robots. That is one thing. But somehow in current scenario, the other real-time examples here is Netflix is one best way, and Pandora, Echo, and Flipkart, and Siri. These are the best way of artificial intelligence we are using in our daily life, in every day in our life. And also the purpose of AI also creates some kind of the career paths in the engineers who can having some interest in this area, like a machine learning engineer, or a data scientist, or a business intelligence developer, or a research scientist, if you want to go for further research in graduation and post graduation, big data analyst, and all these are comes in the umbrella of AI as a different career paths into their particular way. And also machine learning engineer, what they do as a engineer, they becoming a machine learning engineer, and they used to have a knowledge of the computing, and they you have a programming language like a Python, statistics, and software engineering, and they do use their knowledge for solving of problems handling, and their packages are different, and data scientists will process the data according to their skills, like a programming language like SQL, Spark, Python, and all. So the learning of AI really starts with understanding of the basics in our daily life. So we have to learn how machines take the data and process the data and make the decisions. And this includes the topics like machine learning algorithms, neural networks, and NLP is really help you machines to act smarter and useful. So this way, this is artificial neural networks is highly useful. And what we have some kind of research in our center is briefly I will touch for 5 minutes, because it's going to be end the talk. So I believe that academic research is depending upon research and publications, because we all are working in different institutions. Our main prime motto is to be get a research and publications. And research we cannot get it directly the success. First we don't success, but we do, and finally we'll get the success. And very important one is stealing of idea from one person is plagiarism, and stealing from many persons is something like research. This is what our research center is, and these are the areas we taken up in our one machine learning techniques in nanoscale devices. And these are the working models we have been done, and our motto is to be do research in an interdisciplinary way. And like this we have different kind of the sensors, different kind of the smart sensors for RF, means radio frequency range, and as well as the biomedical. These are the faculty members are associated with me, because I'm running the chair of the center, and these are the members are associated with me and doing research with. And these are the scholars are associated. Currently they are working in our laboratory as a PhD scholars and also a part-time scholars. And these are the scholars have been awarded from our center, and these are the MTech students are currently doing, and these have been completed their masters from our lab, and these are the current BTech students. And we have completed 4 funded projects and worth of 32 lakhs, 28 lakhs, and 11 lakhs, and 4 lakhs during of last 10 to 15 years. And like this event, we also used to organize several online platform events, workshops, seminars, funded by the AICT, funded by UGC, funded by SERB and all. From that, we used to have a network, and we used to have a collaborations to improve our knowledge in a different perspectives. So we have published around more than 10 books, and we are the reviewer for a number of journals, and given the technical talks in different events. And we have different platforms of softwares in our center, and also hardware in our center. Mostly we use the TCAD and Silvaco, and in the quantum we are point of view, we are using the Qiskit quantum computing point of view. So these are the some of the publications in our lab as far as Scopus SCI indexed journals concerned. And nowadays we are measuring everything as per NIRF and as per NAC and as per other QS ranking point of view. Whatever published our paper should be connecting with the sustainable developing goals. So far of our publications are meeting these particular ESDGs, and these are the total publications in terms of journals, conferences, papers, books, book chapters, and IEEE. And these are the
The slides are not sharing.
is it so? Where I am, madam?
So welcome slide was showing, sir.
Is it? Oh. Still it is in welcome?
Yes, sir.
It is changing now?
No, sir.
Okay.
So 10 minutes left, sir.
Yeah, 5 minutes. I
Yes,
mean,
yes.
Is it moving, madam, now?
No, sir, see, it was showing same slide.
Same slide?
Yes, sir. No.
It is moving?
Yes, sir.
Yeah. So these are the projects and the scholars and the events what we have organized from our center, and these are the book chapters and books, edited books and facilities. These are the publications and SDCs. These are the peer-reviewed journals, and these are the some of the scientific publications, very important publications and conferences, book chapters, and then very important one is the patents. What we have patent grants and patent publications, and other one is nowadays everybody is facing with this research collaborations, which is very very important for a faculty members. So we should have a national collaborators from IITs, NITs, and private universities, deemed universities, and central universities in our domain. So that we have some resources from their institutions, and what we do part of the work, and they do some part of the work, and combinedly we can go for publication, so that way our publications also strengthen. And also we need some collaborators in at the international level, international, and some of the outreach activities what we did in our center. And this is all about the some of the center activities, which is a volume of more than 700 publications from around 7 to 8 faculty members from last 5 years. So thank you so much for giving me this opportunity, sparing my some of the basic experience on the machine learning and artificial intelligence. Thank you very much.
Participants, any queries, please kindly post in chat box. I was directly communicated with sir. Any queries? Otherwise, we will conclude the session. Thank you, sir. On behalf of our institution and the FDP organizing committee, I take this opportunity to express my heartfelt gratitude to our esteemed resource person, Dr. K. Srinivasrao, sir, for delivering an insightful and enriching session on Introduction to AI and Machine Learning. Your session has given us a clear understanding of the fundamental concepts, applications, and future scope of AI and ML. The way you explained complex ideas with simple examples has truly inspired all the participants. I also thank all the participants for their active involvement and the management of their continuous support in making this program successful. Once again, thank you, sir, for your time and expertise and meaningful contribution of our FTP. Thank you all. Have a wonderful day. Thank you, Silva, sir.
Thank you, madam. Thank you very
Thank you,
much.
sir.
Thank you to all.
Thank you, participants. You can fill the feedback. So feedback link is posted in chat box.
Okay, madam. Shall I
Thank
leave?
you, sir. Yes, sir. Thank you, sir.
Yeah, thank you very much.
Yes.